Have you ever imagined a black hole, one of the most mysterious objects in the universe, doing more than just devouring everything in its vicinity? Picture this. Instead of merely consuming, a black hole sends out powerful jets that might actually be triggering massive explosions in nearby stars. Sounds like something from a sci-fi movie, right? But this isn't fiction. This is real science, and it's exactly what NASA's Hubble Space Telescope has uncovered. Recently, astronomers made a remarkable discovery that has left the scientific community both baffled and excited. At the heart of the massive galaxy M87 lies a supermassive black hole. But it's not just any black hole. This one is launching a massive 3,000 light-year-long jet of plasma into space. This beam moves at nearly the speed of light, slicing through the surrounding galaxy like a cosmic blowtorch. And here's the mind-blowing part. Hubble has found evidence that this jet seems to be promoting stellar eruptions, specifically the violent explosions of stars known as novae. Before we dive into the incredible implications of this discovery, let's take a step back and talk about what a nova is. A nova is a stellar explosion that occurs in a binary star system, where one star is a white dwarf, a small, incredibly dense remnant of a once normal star, and the other is usually a companion star. Over time, the white dwarf pulls hydrogen from its companion, accumulating it on its surface like a growing fuel tank. When the white dwarf's surface gathers enough hydrogen, it ignites in a colossal thermonuclear explosion. This explosion doesn't destroy the white dwarf, but it does blow off its outer layer of hydrogen in a brilliant burst of light and energy. Once this happens, the process starts over, with the white dwarf siphoning more hydrogen from its companion, waiting for the next explosion. Now here's where it gets really interesting. Hubble's observations have revealed that there are significantly more nova explosions happening along the path of the black hole's jet than anywhere else in the galaxy. In fact, there are twice as many novae erupting near the jet as in other regions of M87. This is unprecedented. What could be causing this? How is a jet of plasma, fired from a black hole, seemingly influencing the life cycles of stars light years away? The jet itself is a powerful stream of energetic particles and radiation, blasted out by the supermassive black hole as it devours matter from the galaxy around it. Imagine the sheer force and energy needed to launch a stream of plasma across thousands of light years. This kind of energy is capable of ripping through space and any material that gets caught in its path. But here's the kicker. The stars experiencing these nova eruptions aren't actually caught inside the jet, they're just near it. So what's going on? One idea that researchers are exploring is that the jet might be somehow snowplowing hydrogen gas onto these white dwarf systems. Picture a snowplow barreling down a highway, pushing heaps of snow to the side. In this case, the jet could be doing something similar, but with hydrogen. This hydrogen, once pushed into the white dwarf systems, could be causing the stars to accumulate fuel much faster, leading to more frequent nova explosions. But this is just one theory. Another possibility is that the intense radiation pressure from the jet is accelerating the mass transfer rate between the two stars in these binary systems. In other words, the jet might be indirectly pushing the hydrogen from the companion star onto the white dwarf at a faster rate than usual. When more hydrogen is delivered more quickly, the white dwarf reaches the critical explosion point much sooner, triggering more frequent nova eruptions. Yet another hypothesis is that the jet could be heating the companion stars in these systems, causing them to swell and overflow more material onto the white dwarfs. However, calculations show that the jet's heating effect might not be strong enough to account for this alone. But the fact remains, whatever is happening, the jet is somehow influencing these star systems in a way that astronomers have never seen before. This discovery is more than just an exciting twist in our understanding of black holes and jets. It's a puzzle that could reshape our understanding of how these jets interact with their surroundings. For years, scientists have known that black hole jets can influence the galaxies they inhabit, but no one ever suspected they could be responsible for something as dramatic as triggering stellar explosions. This finding has astronomers rethinking the role that black hole jets play in the evolution of galaxies and the stars within them. It's also worth noting that this isn't the first time Hubble has observed strange phenomena near the M87 jet. As far back as the 1990s, shortly after Hubble was first launched, astronomers noticed unusual flashes of light near the galaxy's core. These bluish flashes were thought to be transient events, possibly novae, but the early instruments on Hubble weren't advanced enough to confirm this. For over 2 decades, these flashes remained an unsolved mystery. Fast forward to today, and Hubble's newer, more advanced cameras have finally given astronomers the ability to take a broader, deeper look at M87. Over a 9-month period, Hubble revisited the galaxy every 5 days, capturing the most detailed images of its core ever taken. When scientists began mapping out where these nova eruptions were happening, they noticed something extraordinary. There was a clear pattern. Novae were concentrated along the path of the jet, a pattern that was impossible to ignore. This wasn't just a random occurrence. Something about the jet was actively influencing the stars around it. The implications of this discovery are vast. It suggests that black hole jets might play a far more active role in shaping their host galaxies than we ever imagined. These jets could be interacting with their surroundings in ways that go beyond what we currently understand, possibly even affecting star formation and evolution. It opens up a new realm of questions. Are black hole jets influencing stellar life cycles in other galaxies as well? Could these jets be triggering other types of stellar phenomena that we haven't yet observed? What makes this discovery even more remarkable is the fact that it was made possible by Hubble's unique capabilities. Ground-based telescopes, despite their power, can't resolve details in the bright core of a galaxy like M87. The black hole's surroundings are simply too bright, drowning out any faint stellar eruptions. But Hubble, with its ability to peer deep into the heart of galaxies, was able to detect these novae against the backdrop of M87's blinding core. Without Hubble, this discovery might have remained hidden for years to come. As we continue to explore the universe, discoveries like this remind us just how much there is left to learn. Even in a galaxy as well-studied as M87, there are still surprises waiting to be uncovered. And with every new finding, we inch closer to understanding the complex, interconnected systems that govern the cosmos. In the end, this discovery is a testament to the power of curiosity and the drive to explore the unknown. It's a reminder that the universe is full of mysteries, and sometimes the most exciting answers come from the most unexpected places. What else might we discover as we continue to probe the depths of space? What other hidden phenomena are waiting to be revealed by future telescopes, missions, and discoveries? One thing's for certain. With every new revelation, the universe continues to amaze us. And who knows, maybe the next big discovery is just around the corner, waiting for the keen eye of a telescope like Hubble or its successor to bring it into the light. So as we continue to explore, study, and question, one thing remains clear. The universe is far more dynamic and surprising than we ever imagined, and the journey to understanding it has only just begun.